So today I'm going to talk to you about the security implications of the consumer side of IoT, which stands for Internet of Things. So my friend and ex-colleague Billy Rios yesterday talked about infrastructure from an enterprise perspective that you could also kind of deem within the IoT space, but my focus and scope is on consumer-grade IoT devices. So before we get into the good stuff, let's just take a step back and ask ourselves why this is an important question or important discussion to have in the first place. We estimate that by 2020, from a consumer side perspective, what I mean by consumer is being able to walk into the Apple store or go online to an electronics store and be able to purchase IoT devices and install it yourself. And IoT devices, the definition of sensor-based devices that connect our physical world to a virtual world. And by 2020, we estimate that, at least in the affluent nations across the world, that there will be about 50 billion IoT devices. Devices such as online thermostats, fridges, sprinklers, door locks, light bulbs. And by 2020, we also estimate that an average individual will have about 35 to 50 devices that he or she will be able to control remotely. So if you take a step back and ask why the stakes are higher, it's because of the physical implications. It is not a stretch to say that at some point on an average home, that if you have a Windows machine, for example, take a look at XP, for example, that at some point you'll probably have malware. Not when I say you, I'm not talking about the sophistication in this room, I'm talking about the average consumer. And the implications of malware at home has been pretty high. It's been abused to steal financial information or social private information online and things like that, which are bad implications in the first place. But with IoT devices coming into the mix, a malware that is within your internal network at home being able to turn your lights off. I mean, now we're talking an intrusion into our physical space, and I think it's an important discussion to start having today. The other thing to keep in mind is that there are existing IoT devices that are consumer grade out in the market today, and as we look into the future, the technology, the security architecture that's surrounding these devices will progress into the future. So my take on this is that in order to contribute to have a good discussion on how we get into the future securely, I mean, we can have strategic conversations all we want. We'll probably agree to say that we need authentication, authorization, access control, good crypto, and things like that. But I feel to really have a discussion that is meaningful, we need to take a look at currently available IoT devices that are popular. And let's go deep and dig down and figure out what are the issues from an implementation perspective that we need to be talking about so that we don't commit the same mistakes as we build future devices that take us to the next decade. So in order to have that discussion, I'm going to pick on 4 devices, or 4 IoT devices. One is a Philips Hue personal lighting system. So you could go to the Apple store today and or online and buy these light bulbs that you can replace these LED bulbs that you can replace all your bulbs in your apartment or your home or your office with, which then allows you to, from your iPhone or from a website, remotely be able to control lighting in your home or your office. So we'll take a look at the architecture that's been used by Philips and what can go wrong, what has gone wrong. Similarly, we'll pick on the Belkin Wemo baby monitor. In this situation, when I looked into it, it's not a vulnerability that I found the way I did in the Hue lighting system. It was a blatant security design decision that I think put the owners of this baby monitor at risk, and we'll talk about that. Similarly, we'll pick on the Belkin Wemo switch, which is basically a switch you put in your outlet, and then any device you connect into, you can turn on or off remotely from the internet. And the Belkin Netcam, which is basically a Wi-Fi HD camera you can install in your home and you can monitor remotely. I have done this talk 2 or 3 times before, the last couple of months, And I'm happy to announce that it's kind of a last minute thing, but I have a bonus product that we'll do a cursory look at, which is the Tesla Model S P85. I actually picked this car up 2 weeks ago and scrambled last minute to get some of the stuff before I came to Singapore. And I would just want to share with you some of the issues surrounding this car as well. So let's start with the Hue lighting system. This is actually a photo of my living room. As you can see, it's not just controlling the lights going on and off. You can actually set the lights to one of, I think, 6 million colors. The iPhone app is so awesome. You can pick a JPEG or PNG, and if you have 15 bulbs at home, you can drop all these pins to particular areas of the JPEG you pick, and the light will change into that color. And so depending on your mood, you can kind of play around with it and have a lot of fun with it. And also just not just having fun, just the utility of being able to turn on or off. You could be in your bed and say, all lights off in my apartment. Once you really understand the advantage of having such devices serve you, it's really hard to go back. It's really a wonderful product. And so let's dig deeper. So if you buy the starter pack, it comes with a bridge. The bridge hooks up to your router using an Ethernet cable. And then the bridge speaks the Zigbee protocol to the bulbs, right? And so the starter pack comes with the bridge and 3 bulbs, and you can keep extending more bulbs. I think there is some sort of a limit because this is consumer grade, I think about 60 or 70 bulbs at a time to every bridge. And then on the other hand, you have an iPhone app. I think there's an Android app as well, but I don't care about Android as much. So there's an iOS app. Let's just stick to that. And the iOS app can control your bulbs. So if you're local, within your local network at home, it connects directly to the bridge. If you're remote, it goes through the Philips cloud infrastructure, and we'll talk about that. So now assume you bought the starter pack, hooked up the bridge, you have lights, and you launch the Hue app on your iPhone for the first time. The first thing your iOS app will do is say, now assume you're at home in the local network. It'll try to find the bridge. The bridge has an internal IP address and has an outbound connection to the Philips infrastructure. So what your iPhone needs to do is figure out the IP address of the bridge, and the bridge is running a lightweight web server. But in order to figure out what the IP address is, it actually hits this external URL, meetyou.com/API/NUPNP. So what's happening here is the moment you connect your bridge, it gets your DHCP, it connects to an outbound to Hue and says, here's my serial number, here's my internal IP address, and here's my MAC address. So anybody from within your home who hits this URL will get that information. So that's what the iPhone app uses to figure out where internally the bridge is. And of course, for all the web app security experts in here, the external website also has access control allow origin to star, which basically means any website in the world can know you have the bridge Hue system installed and the MAC address and all of that, which is not a great thing in itself, but just an FYI. So once your iPhone figures out where the bridge is and local IP address, it connects to the bridge, and I'll show you the post request your phone will send locally to the bridge. But the moment that post request is sent, you'll see this image in your iPhone app. There's a button on the bridge that you need to press within 30 seconds. And so it's basically the security mechanism here is that you're proving physical ownership of the bridge. And if you press the button within 30 seconds, your iPhone is now authorized to issue local commands to the bridge. So here's the post request that the bridge sends to the bridge, your iPhone sends to the bridge. Basically, it contains a username, which I deleted in this case. And so username is basically a session token that your iPhone app picks. It could be anything. And then if the user presses the button on the bridge within 30 seconds, the bridge responds with an OK and says, from now on, the username you just gave me is your session token and it's valid forever. One of the things I realized as I was kind of man-in-the-middling this stuff is that for my particular iPhone, no matter how many times I reinstall iOS from scratch, that the session token that the iPhone was picking was the same every time. And the session token looked like an MD5 hash. So just based on a guess, I took the MAC address of my iPhone, computed the MD5 hash of it, and that was the token that my phone was picking every time. And from a local perspective, you can see why this is a really big problem. Now, keep your eye on the future. So 2020, you have 50 devices within your house. Do you really want your thermostat to control your light bulbs if there's malware? So here, the whole idea of, well, it's within the local network is out the door if you're going to have 30, 40 devices at home in the future. So to demonstrate this issue, assume one of your Windows workstations gets owned. What could a potential next generation malware do to exploit something like this? So let's just talk about this Hue Blackout bash script. So here what I do is I connect to that external URL, assume this is a malware script, that's running on a machine that's been owned, connects outbound, sees if there's a Hue bridge, and if the answer is no, it sleeps for 10 minutes, tries again. When the answer is yes, it basically does an ARP-A to see what MAC addresses are flying in the air. Remember, if you're already on the network, the MAC addresses flying in the air are public information. Takes each of the MAC addresses, computes the MD5 hash, connects to the bridge, issues a lights off command, that's the /group/0/action. And the moment that is successful, it goes into an infinite loop and just says lights off, lights off, lights off. And it sleeps for about half a second to give the bridge some time to recover. So let's see what this looks like in action. On my website, I also have an extensive paper that talks about a little bit more in detail that I'm able to cover. So if you really want to figure out what the architecture of the system is like, feel free to read that paper. So now what you'll see is a victim browsing to an external malicious website and the lamp goes off. Right? And so now let's look at, in slow motion, the perspective of the attacker. In this case, the attacker is manually going through the Metasploit session. We could automate this, but this is just here so that we can look at it step by step. In this case, there's a Java exploit that has been issued. The victim is vulnerable. And then the attacker uploads the script that I just talked about and basically launches it. Now, the script will be successful. The victim will have a blackout. There is a good solution to this. Right, it was a temporary solution. But in this case, the victim is, lighting the candle, and then he realizes, wait a second, my gadgets still work, and my neighbors still have electricity. There's something really wrong here. And so what you can manually override is, you turn your physical switch off and on, and it tries to override, tries to get the light bulb on. But remember, the malware script is an infinite loop. So the lights come back on for a few seconds, and you have a blackout again. It just keeps repeatedly going on. You're also getting a mini tour of my apartment, by the way. So what you can do is unplug the bridge, in which case you can manually override it and you get your lights back on. But now you plug the bridge back in. I'll let you guess what happens. If you're a power user, you can go to the API debugger on the bridge and unregister your device. And if you can do that, you're safe again. But guess what? Your iPhone doesn't work anymore. And the script detects that. And it goes back into the ARP table, tries it again. The moment you take the same iPhone and retry associating it with the bridge, let's go back up again. So you get my point. So that's one issue. I tried contacting Philips 3 times. The only way I could contact them was through their Twitter. I direct messaged them, and they said, within direct message, they're like, just give us the information. And I said, well, 140 characters is really tough. And they said, it's okay, just keep going. And I said, no, I'm not going to type this shit in Twitter. In about 2 months of trying that, this stuff got public. And I actually had a great discussion with the main IT executive about this, and since then they have fixed the issue. So there's other things to talk about here, right? You don't need the iOS app. You can just go to the meetyou.com website, put in your username and password. The password requirement is 6 characters. Your password can be 1, 2, 3, 4, 5, 6, and it works. The saving grace here is that there's a 1-minute lockout for 2 failed attempts, so that's good. The question to ask is that in some sense, companies like Philips now are becoming private owners of critical infrastructure, right? Where you could have a sustained blackout that has nothing to do with the grid itself. And so as we start to kind of take a look at the implications of lights going off in an apartment or a high-rise condo, and the only thing we're using to protect that is a 6-character password. And then we have issues where people have a tendency to reuse passwords. We have password leaks, thousands of password leaks almost on an hourly basis where other software is compromised. And all you have to do is kind of look at those usernames and passwords that have been compromised from other web applications and just try if it works on Philips. And if it does, now you have ownership to that. So I think my point here is that we really need to be thinking through when it comes to IoT, just the blending into our physical space. We can't be protecting these things like we have protected ourselves in the past, a 6-character password. The other thing to think through, and this is not just for Hue, is that in order for all of these different IoT devices to start to work and do the things we want them to interact with each other. There's projects like If This Then That. It's a wonderful project where what you can do with IFTTT is go to the website, sign up, and then you can, using OAuth, authorize your Gmail, authorize your Facebook, your LinkedIn, your Hue system, and you can connect all of these things to one dashboard, and you can say things like, if my grandmother emails me, make my bathroom lights go off. I don't know why you would do something like that, but you could. And people could probably come up with more useful examples like that. So you can kind of see where you have one platform that's kind of blending in the physical, social, and online spaces. And the concept of If This Then That is to build recipes to make all of these things talk together. And I really think we need to be careful about this, because here's an example of a recipe. It says, when I'm tagged in a photo on Facebook, change my hue to reflect its colors. Well, what if I tag you in a black photo? All your lights go off again. So I'm not sure how analog, because how you could decide if one recipe is more harmful than the other. But I think we really have to be careful about this. The other thing we have to ask ourselves is, if IFTTT is a platform where you have authorized your IFTTT account to have access to your Gmail, your Facebook, your Hue, your baby monitor, and all is connected in one place, then how do you guard the IFTTT infrastructure now? Because now it's just this powerful hub that is connecting your virtual space with your physical space. And as we'll look at the other products, one of the themes you're going to find me repeat is that if I'm a malware author today, what do? I want to set up a botnet. I will author my malware, and what does my malware today do? In most cases, it will own your machine using an exploit or having you double click on an exe. And then once my malware is installed, I want to look at other computers that are in your network that I could infect and connect back to the botnet. While I'm doing that, all the machines that are infected, I'm going to keystroke log everything I can, right? I mean, this is just a vanilla malware that we're used to love now. But the future, if I'm a malware author, not only am I going to do all of these things, but I'm going to scan internally to see what IoT devices you have. For example, the signature for Hue would be connecting to the external URL to see if there's a bridge there in the first place. So my point, if you take home anything in this presentation, is that unless we start to talk about these issues now and fix them, we're going to have the exact same problem of malware, but in a new way where it's not just going to look for other computers, but also physical devices within our homes. Let's move on to the baby monitor. So the baby monitor in this case is just an audio device here from Belkin. You connect it to your Wi-Fi network locally, and then you have the iPhone app. I believe there is no Android app for this one, it's just the iPhone. And then the baby monitor and the iPhone app use SIP to connect, so you can listen into your baby. By the way, the implications here is not what your self-proclaimed cute baby is saying. It's really about somebody invading your privacy to overhear your conversations using a device like this. Before I could, so I don't have any kids that I know of, but I did purchase this device to start to take a look at, how things work. But even before I was able to unpack this thing, I read this review on Amazon by a non-technical expecting parent, and he says, it has very poor security model that leaves the Wemo open to unwelcome monitoring. The Wemo allows any iOS device on your local network to connect to it and listen in without a password. If that's not bad enough, when an iPhone has connected once on the local network, it can tune in later to the monitor from anywhere in the world. This is by design, right? And let me prove that to you. Again, I have a paper on this as well as the switch on my website. It's pretty lengthy, so if you want to get into more details on what's going on in the background, feel free. So I'm launching the Wemo Baby Monitor. Now I'm on the local network, right? It finds the device. And then you can just click on listen. I love that it buffers. It's like reminds you of Real Player. There we go. And then you're listening. And just we'll stop it. We'll get out of the app. And what I'm going to do here is disable Wi-Fi. So now we're connecting externally through 4G LTE. You relaunch it from anywhere in the world, and you have access to it. So I know what you're thinking. You're thinking, well, is it about my creepy friend that shows up to my house and requests for my Wi-Fi password, and then he or she can listen? And it's really not about that. Because if you look at the underlying architecture, imagine, again, if you're a malware author. What we're basically saying is if you have one-time local access, you're in. If you were to write a script that's in your internal network for a couple of seconds, what you would do is use UPnP, the baby monitor responds, you get the baby monitor serial number, the IP address. You basically connect to this, issue this post request to the web server that's running on the baby monitor. You pick a device ID you like, and then you're in. It'll respond back with a smart private key, which is the serial number of the baby monitor. And once you have that, you just connect to this external IP address using a SIP client, and your from address is the ID you just picked, and the to address is basically the serial number of the baby monitor. And then from now on, forever, you can listen in. And so my concept here is, again, that if we are going to have the baby monitor, if you're going to have the Philips Hue lighting system in your own local network, we can't really be trusting devices that are on the same local network. Quickly go to two more products, and we'll go to the Tesla. So similarly, Belkin makes the switch, the exact same thing. It connects to your Wi-Fi. You have an iPhone app that you can control from anywhere in the world to turn the switch on or off. And it's the exact same protocol as the baby monitor. If you're in, if you're local, you can just connect to the switch and say off, on, off, on. And there is no checks. If you're local, you're in. And you can kind of start to see how this could be exploited. In this case, if you want to write an annoying script that once it's in, where to turn the switch off every half a second or 5 seconds, it's basically 1, 2, 3, 4 lines, right? And so right? And here's the victim trying to, lights are on, it goes off. You try to turn it back on, it's already off. Yeah, so it just in an infinite loop. So it's the point I keep trying to make, is that we have accepted that in the enterprise, flat networks are a bad idea. And we haven't done much about that in our homes. But I think as we look into the future, we have all of these devices. I think a lot of high-rise condos are coming inbuilt with some of these devices. We ought to make sure that the vendor understands, as we're consuming these devices, that it is not okay to design devices that explicitly trust each other even though they're on the same network. This was a really quick one. This is also by Belkin. Wi-Fi HD net camera. In fact, this one, I was pretty convinced that there's really not much to report. Everything was SSL. The camera connects outbound through SSL, TLS. The iPhone app connects outbound. There's no local trust. Strong password requirements. Pretty well done, right? I was about to write this one off until I was just kind of sniffing my local network, and I saw this random UDP packet in Clear fly by with my username and password. I still haven't figured out what this server is and why it's going there. And so all this hard work on architecting this with TLS is just out the door. It's probably some sort of a debug code that was left in there. I did contact Belkin customer support with this exact screenshot. In fact, I had more details than I trust you guys with that I showed the Belkin support people, and the responses I got back was, "What is Wireshark?" And so I said, "Well, it's a sniffer." Well, I said, "What is a sniffer?" And so my response, and it was really polite, I said, "Look, you really need to figure out the right person in your team, because if you find the right person, it will make sense to them. I can't really help you with that." And I haven't heard back since then. So, if someone were to invade you, think about it. In the US, for example, I'm kind of ignorant about Singapore here, but Comcast, AT&T, they're major ISP providers. If somebody were to just kind of sniff this one particular UDP traffic, I could guarantee you there's tens of thousands of these net cameras, and your password is just flying out in Clear, and you don't even know it. That could allow anybody remotely to be able to view you. And so this is really we really need to be taking this very seriously. Tesla. I'm a big fan of Elon Musk. I think after Steve Jobs passing, this is one guy that I look up to. He's very inspirational. I purchased a Tesla about 2 weeks ago, and I love the car. It is a fully electric car. And just to give you some perspective, it is not a joke. This is not a toy car that you can just write off to say it's an electric car. A lot of times, the last electric vehicle I sat in was a golf cart, right? And so just to give us some perspective, this thing has 416 horsepower. It goes from 0 to 60 miles in 4.2 seconds. And this is really the car of the future. And I think what Elon is doing is amazing. They're building all these supercharging stations across freeways where they're selling Teslas, and you get to charge your car in 40 minutes, 0 to about 250 miles per hour, 250 miles of range in about 45, 50 minutes, and it's free for life. And they're maximizing solar. So I think if you want to sustain life, solar is the only answer. So I'm a big fan of Tesla. And so I haven't had much of a chance to be extremely intrusive with the technology, but I did notice a few things that I want to share with you. So when you buy, by the way, Chris Christie, do you know who that is? So government, is he a governor or New Jersey, who's kind of banned the sale of Tesla because apparently the dealers lose out, and I don't know how this is bad for the consumer. But so if you were to buy a Tesla, you have to set up a Tesla account, and you pick a password, 6 characters. The requirement 6 characters, but it has to have 1 number and 1 letter. Once you pick the password, you order your car. Depending on which model you get, it shows up between a month to 3 months. And then moment you pick it up, within 24 hours, you download the Model S iPhone app, you log in with the same credentials, and you can control various parts of the car. Now, granted, you cannot, as of the design of the app, turn on the car. By the way, there's no such thing as on in the Tesla. As soon as you get in with your key fob, it's in park, you just go to drive. So there's no concept of on, but the car won't drive unless you have the fob. But with this iOS app, you can unlock the car and you can know where the car is. So let's just take a look at those two use cases. And so my point here is very simple. We cannot protect our vehicles like we protect our workstations. So 6-character passwords, no brute force limit. You can brute force the Tesla website with a particular email address for as long as you want. And the moment you're in, you're in. Not only are you in, you can see where the car is, go near it and unlock it. So there's that one clear attack vector there. Phishing attacks. I mean, if you're launching phishing attacks, I mean, imagine setting up a domain, teslamotors.com, where instead of the M, it's R and N, so it looks like an M. You know, things like that we've known for years on how to do. And imagine you were to harvest, say 10,000 or 5,000 Tesla accounts, like that. Tesla also has this REST API that the iOS app connects to, and it's not intended for third parties to use. It's purely designed for the Tesla iOS app. It's a very simple API based on a lot of GET requests. So you could kind of see how you could automate this if you were to launch a phishing attack against Tesla users. Once you have the username and password, you basically point your domain to portal.vn.teslamotors.com, submit to login with the credentials you've captured. If you get a session token back, you're in, and that session token is valid for 3 months. Once you have the session token, you issue a GET request to vehicles. You're looking for the vehicle ID, which is not the VIN. Once you have the ID, you can issue commands drive state, which returns a lot of things about the vehicle, including the longitude and the latitude. And now you can have this table of where all these cars are, all the credentials that you have fished. Pick a car that's nearest to you, go near it, and then issue a GET request to vehicle's ID, command, or unlock. And so, I mean, this is really basic stuff here. Malware attacks, you can kind of see if I were to write malware that infected your workstation, I want a keystroke log every time you're logging into the Tesla account. And also the website, when you log in, I think the session token is valid for a long time, so you can just steal the cookie. And we've talked about the concept of password leaks. I mean, imagine, I could guarantee you that more than 60 to 70% of Tesla owners, the password they've picked, they reuse it in other applications. There's also the social engineering Tesla support. I know Apple has had that problem recently where people were social engineering the Apple customer support and resetting people's iCloud accounts. In this case, there's a forum posting. I'll read it to you. Just a reminder, this is a Tesla owner on the Tesla forum website. Just a reminder, if your key fob is in your bag and you're able to walk up to a door, including the rear hatch, and unlock, blah, blah, blah. Okay, well, so he gets locked out. Fortunately, Tesla can remote unlock your door, and I called the support number, and Freddie, I believe it was, helped me out, and it was fantastic. Calling back a few times to make sure everything was cool. So this person called Tesla customer support, and a nice guy called Freddie unlocked his car for him, which is great because all the Freddies I've known are just such nice people, right? But this concerns me, right? I mean, last time I called Tesla support, they wanted the last 6 of my VIN, which is on my windshield. The other information I think Tesla has about me is my driver license information, because that's on my profile. So I'm giving Freddie some benefit of the doubt. Maybe Freddie did verify that information, right? But I don't think it's enough. And it's not clear. Because the last time I went to a car dealer and took drove around the car, they took a photocopy of my driver license, right? So other people have that information. So it's really not clear what's going on. It's not clear to me as a owner which employees have access to this information. Which employees can see where my car is, where I'm driving, and be able to unlock it. Don't get me wrong, I think the usability, the functionality, when I'm in need of help is fantastic. I'm not saying that Tesla should do away from this service. They have fantastic customer support. They're able to monitor your car. If there's something wrong with it, they call you proactively and send people out. So they're doing a good job, but I think we really need to be careful about the power that's entrusted within their local employees. So if you're a Tesla owner, one of the things that I highly recommend is if you have a Tesla profile, set up a brand new Gmail account that's exclusively used for this purpose, enable two-factor auth, and associate that with your Tesla account. The other issue is that I think Elon Musk has publicly stated that they are diligently working on an SDK. I'm assuming that SDK will be a combination of libraries, combination of a sandbox of some sort, and an API, and a vetting process in the way that the Apple Store does to be able to allow certain apps to run externally and within the Tesla environment. And Tesla has said publicly that the REST API that they have exposed today is not meant for third parties to invoke, but people are doing it anyway, right? In this case, there's a Google Glass Tesla app. So if you want to monitor your car from Google Glass, you basically install the Glass app, then you go to teslaglass.appspot.com, and you actually type in your Tesla credentials, and it goes to a random third party. That party in turn connects to the API. So the problem here is that I know Tesla is doing the right thing by trying to perfect the SDK environment they eventually put out, but in that meantime, we have a lot of people that are using these random third-party applications that are not vetted by Tesla and giving up their credentials to a third party. So this is something to really watch out for. And this is not just to poke at Tesla. I can imagine there's other cars that are also controllable in this way that we should be asking these questions about. The other, and this is more of a maybe a medium risk issue, is that if you lend me your key fob, it's difficult for me to clone your key fob. If I return your key fob back to you and you trust me with it, I think you're pretty much safe. It's a little bit more complex to clone it. I don't have the expertise, but people do have their, I'm sure there are people who have the expertise, but it's a niche field. However, if I have temporary access to your iPhone, the session token that's stored on your iPhone is valid for 3 months since you last logged in. So, there's just the concept of your iPhone, or I think there's an Android app as well, being trusted for 3 months at a time. If someone were to have temporary access to it, or backups, where that session token is stored, it's probably not the greatest thing. So I would imagine in the near future, if in iOS 8, for example, if Apple were to allow third-party apps to leverage the Touch ID functionality, that would be something that if Tesla were to built in to unlock the car, I also have to have my fingerprint in addition to having ownership of the phone. I think that would be a much, much better and safer way of doing this. The other part that I have not personally tested, but I've gotten this information from elsewhere, from a forum, is that there's actually a weird Ethernet jack on the left of the dashboard. You connect your laptop to it, and you see these 3 IP addresses running SSH, NFS, X11, HTTP, domain, RPC bind. And if you were to put on Wireshark and just kind of look at the traffic that's flying by, it's a lot of overwhelming UDP traffic, a lot of censored information. Now, like I said, I was able to capture some of that traffic, but I haven't had time to parse it. But if you have a Tesla lying around, if you have friends, this would be, I think there's a lot of low-hanging fruit here. I am a little bit hesitant to be intrusive with this, unless it's somebody else's vehicle, because, especially with the NFS mount, I think that is more, in this case, just read-only with navigation information. But, I would imagine there are things you could be doing that could potentially break the car. And if you were to, I wonder if that would be out of warranty. So there's lots of low-hanging fruit here that I think we should watch. By the way, a lot of the things that I talked about they're not vulnerabilities per se. I'm just calling out some design decisions, right? They're not intentional vulnerabilities. However, if you were to find Tesla, actual vulnerability in Tesla that is unintentional from Tesla's part, they have an awesome mechanism where it can be reported. So thumbs up for that. And I actually, all the stuff that I've talked about, I have communicated it to Tesla, and we have an ongoing thread about that. So they're really great at talking to owners about this. So I thought you might enjoy it. It's just a cursory look. The takeaway from this is, as we start to look into the future, I mean, things like cars that are so powerful, we really cannot be protecting these things the way we have tried to protect our workstations and failed. Owners need to be cognizant about the risk that they're leaving on the table. And I have full faith, given the nature of all the Tesla people that I've interacted with, Elon's personality, that they're in nascent stages, but I think in the near future they'll be more transparent about exactly how the underlying structure works so that we feel comfortable about it. That's all I had for today. I can take questions if you want. All right.
Does Tesla use the navigation system, the car's navigation system? Because there was a presentation at DEF CON on how you can mislead, by sending bogus data, you can mislead the car and tell them like the bridge ahead is closed.
Right. So Tesla does, for the map information, the real-time maps, so if you want the satellite traffic, it had an always-on 3G connection that's outbound, and I think it uses Google Maps for that. Now, the moment you don't have 3G, it kind of uses the local information, the compass and accelerometers to guide you, but you won't have up-to-date detailed maps.
The up-to-date stuff
Yeah, but that comes through 3G for sure. The Tesla also, what I didn't cover, is it can also hop onto Wi-Fi when available. So when you're back home in a garage, you can hop onto Wi-Fi. And if you were to sniff that, what you'll see is OpenVPN being used to connect back to Tesla, which is a great thing. However, what that tells me is there's a shared secret somewhere. Either it's using certificates or there's a static shared secret. So that would be interesting to test. Yeah. All right, well, I'm hanging around here for the next couple of minutes. Come say hi. Thanks.